Hi everyone, my name is Lee Pucker. I'm the CEO of the Wireless Innovation Forum, and I'd like to welcome you to the 30th of our webinar series. This is a refresh of our previous CBRS introduction, where we're going to give an update to everything that has happened since then. A few administrative notes before we get started. I see that I already have a question about, are the slides going to be made available? Yes, the slides will be made available. Go to wirelessinnovation.org/webinars, and later today we'll have posted the webinars. They are not in the handouts, but they will be posted on wirelessinnovation.org/webinars later today. We're also recording the webinar, and it'll be available on our YouTube channel. I've got the link here, but if you just go to YouTube and do a search on Wireless Innovation Forum, you can find us. And finally, if you have any questions or need any information, any additional information, please contact me at lee.pucker@wirelessinnovation.org. For questions today, please, there's a questions window on your screen. Please type the questions into the questions window, and I will be moderating the questions and passing them to the speakers at appropriate times. So with that, let's go through the agenda. There's going to be 3 presenters today. The first is going to give a CBRS overview, and that's from Richard Bernhardt, the National Spectrum Advisor for WISPA. The next will be a presentation on the practicalities of sharing CBRS spectrum with others from Andy Clegg, the Spectrum Engineering Lead at WISPA. And then finally, we're going to close with how CBRS has developed since commercial service began by Mark Gibson from CommScope. And
hey, Lee,
so,
just one quick correction. I'm from Google, not from WISPA.
Oh, geez. All right. Sorry about that. I will correct that before I send the slides out.
You're welcome, though.
All right. So Andy Clegg, Spectrum Engineering Lead from Google. All right. With that, I will turn it over to Richard Bernhardt, and take it away, Richard.
All right. Welcome, everybody, and thank you for joining us again here at WINForum for a CBRS updated version. This is we'll begin with a refresher, and I am going to cover a lot of ground today. So you will see a lot of slides. I am probably not going to cover all the material that is on the slides verbally, so the slides are available if you want to go through them. We started with this stuff about 7 or 8 years ago, and it's amazing to look at where we are today, and we thought it might be a really good idea to kind of give an overview again of where CBRS is, what CBRS is about, discuss the implications of where things have gone, but we got to start with talking about what the whole thing's about. Let's go to the next slide. Lead, next slide, please. Thank you. So we have to do these things called the awful disclaimer. So I'm going to do this one quickly. This webinar and its contents in whole or part are protected by copyright and other intellectual property protections. No portion of this presentation may be copied or otherwise used without the express permission of the owner or holder. Any references or referenced copyrighted materials or other intellectual properties belong to their owners and no rights are conferred herein. No information provided in any way is offered in the form of a legal, business, or financial advice or direction. You're just watching this to watch it. Nothing contained in this presentation may be taken or construed as a recommendation, and the accuracy is given as is with no warranties or guarantees, and it may contain mistakes or things that get updated when someone watches this a year from now. So the information contained here is for your background consideration and for users, and users are advised that if they have specific questions to seek out professional advisors or counsel where needed. Now, let's have some fun. Next slide. All right, like I said, lots and lots of stuff to learn and know. Some of it you know, some of it you don't know, some of it you'll learn, but let's start at the beginning. You know, why CBRS? We're going to talk about the band and its component parts. We're going to talk about incumbents, what it means to be an incumbent, and what it means to be in the shared spectrum. We're going to talk about how the band is controlled using the SAS, the Spectrum Access System, its powers and directions, and what it does for frequency assignments, allocations, grants, and other things. We're going to talk about how the incumbents are protected and the use of ESCs and some potential alternatives that may be coming down the road for ESCs. And I believe Andy or Mark will go into much greater detail on some of the protections and protection areas. So I will touch on that loosely, and then they will go into more detail. You will have the ability to know about shared use, what it means to have both commercial and federal uses in the same band, our tiers of use, what that means. Some of you own already PALs. Some of you may access a PAL from a secondary market, or some of you may not have PALs at all, but you still need to know what a PAL is if you use the ecosystem. So we'll talk about PALs. We'll talk about GAA, the generally authorized access, and the implications of the two in the different parts of the spectrum. We're going to talk about the ecosystem when it comes to equipment. What does it mean to use a CBSD? What does it mean to use an EUD? What kind of antennas can you use? How do you install these things? Do I have to use a CPI? Do I not have to use a CPI? What's a CPI? We'll be talking about a whole range of things around registration, including some of the materials that you have to relay to the SAS when you're registering your device. This is a band that does interact with the federal government, and so there is some security involved with the band. And so we'll talk about PKI, and we'll talk about certificates of authentication and where they're used and how they're used. We'll talk about some changes. If you have to change something, what do you do? How do you move your CBSD if you need to move it? How do you change your band? How do you get a new grant? How do you lessen your grant? Things like that. And that, of course, includes what frequencies you can use. We'll talk a little bit about the transition from Part 90 to 96 that took place and is kind of ending next year and what that means. We'll talk about Category A and Category B, the different levels of power and devices. We'll talk a lot about the baseline standards or release 1 in CBRS, and then we'll talk about what's happening today in release 2 and things that you can contribute to if you want to about enhanced features, functionalities, capabilities, and other things, some that have no impact whatsoever on the rules, and others which might, which would be regulatory impacting versus non-regulatory impacting. And then we'll go into the thing that most of you will have a benefit from directly is what markets can you use CBRS in and where is it being used today, and then answer that question that goes all the way back to the beginning of this long tome of agenda, why CBRS? And I hope we'll cover a lot of that to your satisfaction. Next slide, Steve, please. All right, Lee, there we go. So what is CBRS? CBRS is 150 megahertz of spectrum from 3550 to 3700 in the megahertz in the band, in the spectral band. It's 150 megahertz wide, and it's generally broken up in segments of 10 megahertz. It is what's called flexible or shared band. What that means is that there were and are incumbents in the band. An incumbent is someone who already resides in the band and has uses in the band, and they will be sharing it with another entity. And in order to protect those entities that already have a use in the band, there has to be a methodology to do that. And that's where SASs come into play, and that's where some of the rules come into play. CBRS is a diverse and neutral band. Neutral technology-wise. It's regulated by, if you want to look up, Part 96, and we'll go into some greater detail on Part 96 as we go through these materials. But Part 96 is the governing rules of the FCC, and they're the basis upon which WINForum has created the baseline standards that go with the rules. And the band itself is technology neutral. And what that means is that there can be all kinds of different equipment, there can be all kinds of different interfaces, and there can be all kinds of different uses. And they have to sort of live together in coexistence. And we'll talk a little bit about coexistence. And it's open to various markets. In my work, both with WINForum and with WISPA and with groups like OnGo Alliance and others, there's well over 100 different vertical markets that I've seen CBRS already deployed into with many, many different uses, some very, very small some in things like IoT, where various things are being monitored, all the way up to apartment complexes and schools and residences. So what does CBRS do for you? It provides you with the best of all worlds. It gives you some license type use. It gives you some easier access license by rule use, and it allows you to diversify in your overall use. Next slide, please. So who are the incumbents and why are we protecting them? First and foremost, the #1 incumbent in the band, and they show up primarily in the bottom 100 from 3550 to 3650 are the federal government, who has such uses as the U.S. naval radar systems. There are various kinds of radar systems that operate, and most of them are shipborne. And they operate along the coastal waters of the United States, though there are some that come inland. There are some training areas in the United States along the Mississippi River and in other areas that also need to be protected. And because of the sensitive nature of things like government radar systems or naval radar systems, sometimes the government doesn't want us to know exactly where they're originating from. So there are devices called ESCs, Environmental Sensing Capability Networks, which are offered by various private entities that detect the activity that goes on in the waters. And sometimes those detections are made even if there isn't something going on. It's called obfuscation. And the reason for doing that, if you ever get a DPA called and you think, gosh, there's no ship out there, if you knew that, the reason is because the government doesn't want you to triangulate or know exactly where the ships are. So the first and foremost incumbent in the CBRS world is the federal government. Next, we have fixed satellite systems. These are ground-based Earth stations that relay signals on various sites. Those that were going into the C-band, some of those have been moved out, some are still operating. Most operate 3625 to 3610, and they have to be protected from interference. And that's one of the jobs that the SAS does through CBRS. The third incumbent is the one that's sort of going away, but there are still some of them left. I mentioned part 90 to 96 in my introduction. Before there was CBRS, there was the 3650 band. The 3650 band runs from 3650 to 3700, and it was governed, instead of by Part 96, is governed by Part 90Z. And Part 90Z is rapidly fading into, by order of the FCC, is fading into Part 96. Now, that does not mean anyone who has a Part 90 device or operated with a license in 3650 has the ability to automatically transition into Part 96, but most of the operators who had valid 3650 licenses are doing just that. They're requesting to enter the ecosystem just like any new operator would, and they become part of the band. The issue that has to be known is that they have the ones that existed back to 2015 and were properly registered with the ULS. Those operators have general protections which the SASs will protect. There are not many left. About maybe 15 or 20% of those licenses are still operating and will be operating into some part of the late next year in 2023. But after that point, there will no longer be any grandfathered wireless protection zones, and that issue will go away. Next slide, please. All right, the spectrum access system is a really important component to CBRS. It is the central control location. It is the guiding coordinator of the band. But one thing you have to know about SASs is they are also private businesses. And there are a number of SASs that operate, and they operate a little bit differently, each one of them having their own offerings. But they're all garnered by Part 96, and they all follow, substantially follow the WINForum standards. And they are designated in Part 96, if you want to look them up, at 9653 to 9666 gives the governing rules by the FCC of how a SAS is to operate. Its main function is to protect incumbents, the incumbents we just mentioned, within the spectral range that I've indicated, as well as to take requests for frequency and for power, and to give grants where appropriate to protect the incumbents. They coordinate the band, and they do the things which are necessary to keep the band operating. And in many cases, they will refer to other databases. And once a day at this point, maybe more in the future, they collaborate with one another on a thing called CPAS, where they compare notes to make sure that everyone understands the coverage of their various areas, so that incumbents are best protected. Next slide, please. All right, so these are all of the incumbents that need to be protected. I've mentioned a few of them: the federal radar systems or the federal systems, the fixed satellite systems, which are governed, by the way, if you want to look them up, under Part 96 at 96.17. They generally range from 3,600 to 3,700 in the band. The federal radar systems are on the lower 100 band, 3,550 to 3,650. Grandfathered wireless broadband licensees are substantially either 25 megahertz of frequency or 50 megahertz of frequency, and they would be recorded in the Universal Licensing System, or the ULS, and they have to have followed specific rules in order to get grandfathered wireless protection. You'll generally find them in 3,650 to 3,700, which is the top 50. There are other protectees that the SAS will look over and CBSD operators have to follow, and that is borders with Canada and borders with Mexico. US regulations and treaties often govern radio flow over borders, and it's really important to make sure of that. CFCC Part 9621. Also, official quiet zones. These are places where the government and other entities test radios and do other functions where they need to have RF quiet areas. Oftentimes, these quiet areas have the ability to coordinate, but the rules around quiet zones have to be known on a location by location basis. And if you are coordinating, it needs to be coordinated as well with the SAS, so the SAS understands if you're doing something like that. And the final one is absolute, and it pretty much applies to all frequencies, but it also applies here in CBRS, and that is if a presidential order happens that spectrum needs to be cleared, moved, or otherwise changed for a particular reason that the president may give, that needs to be followed. So we have federal systems, FSS operators, grandfathered wireless, borders, quiet zones, and presidential orders, which are essentially the areas of those that are either incumbents or need to be protected. Next slide, please. All right, we talked about ESCs. So along the coast of the United States, the ships that bear the radar systems need to be detected, and a zone is created when those go on, and a declaration of a dynamic protection area is made, and the SAS has to protect the government, or needs to protect those radars from interference. So ESCs are located along the border of along the coast of the United States, and a couple of other locations and islands and other places where the radar systems can be detected, and the SASs interact with them in order to make the protections done as they need to be. When a dynamic protection area is called, and a protection area can be between 150 and 250 kilometers, depending upon its specific region. The other thing that needs to be protected is the ESC itself. So the ESC, because it's a radio sensor that's very sensitive, the SAS will protect the ESC and the surroundings around it. And when a DPA is called, they will also protect the area that needs to be protected to make sure that the incumbent is not interfered with. The United States government, and I believe Andy will talk about this a little bit further, is considering an option which may replace ESCs called the incumbent informing capability. It would do away with the need for sensors and employ a different approach. If that happens, we don't know when or how it will happen, but if that happens, it may be a replacement for ESCs. And what happens when a DPA is declared, when an ESC notifies the SAS that there is a activation or a protection that needs to happen? The CBSD has to, within 300 seconds after that declaration, it has to either shut down or move according to the SAS's direction. Next slide, please. Some people fear that the CBRS band is all about the government closing them down. Honestly, that hasn't been a big issue. There are some instances where it does happen, and you have to be aware of it coming into the band, and no one will tell you otherwise. but you know, if you plan properly and there's approaches properly, you should be okay. So there are two distinct portions of the CBRS band. First is 3550 to 3600, which is called the lower 100 megahertz of the band, and that's occupied by the federal incumbents, PAL holders, and in some FSS users, and opportunistic GAA and GAA. 3650 to 3700, the upper 50 megahertz of the band, is occupied by some FSS systems. The grandfathered wireless licensees, those are the ones that I said were going away in 2023, and is substantially a GAA band. All right, let's move on to the next slide. CBRS has several tiers, and based upon the frequency assignments that are given, it depends upon what tier you're in. So there's PALs and there's GAAs. The PALs, priority access licensees, were done by competitive bid in an auction 105. They are 10-year licenses or 10-year rights of access with renewal capability as federal incumbent, with rights of renewal. They have to follow certain rules, and as a holder of a PAL, you only are acting as a PAL when you ask for PAL protection and ask the SAS for PPA. So that portion which you occupy with active CBSDs, that's what's protected. Let's move on to the next slide. So the area of the protection is called the default protection contour, and it's protected by the SAS. And we'll go into more detail about that in a little bit. Move on to slide 15. All right, PALs are, if a PAL is not being used, then the rest of the spectrum is allowed to be used opportunistically as GAA spectrum. And GAA spectrum is open to any party that wants to use it. And it's not even a first come, first served basis. GAA is open if someone requests it and there isn't an interference that needs to be protected against. The SAS will give you opportunities to use that. Move on to the next slide, please. All right. GAA is the generally authorized access tier, and it is licensed by rule. 3650 to 3700 is reserved for GAA, but GAA may also operate in the lower 100. There are 7 slots that were allocated for PALs, and then there's 3 additional slots available in the lower 100, which are GAA use. And again, any other spectrum that is not used by a PAL is available for GAA on a shared use basis. All GAA operators are expected to play nice in the sandbox. If you look at section 9635, that means you need to cooperate with one another. SASs are not required to coordinate GAA operators for coexistence, but some of them do willingly and will help with that. But all operators are required to do coexistence on their own. Let's move on to the next slide. All right, can anyone use the band? The answer is yes, anyone can use the band as long as they're authorized by the FCC to be in the band, and there are certain requirements that you have to meet to do that. GAA is considered licensed by rule, but you don't have to go get a formal license as you would with licensed frequencies. It is open to anyone, and as I said, you need to play nice in the sandbox. Let's move on to the next slide. The ecosystem of equipment is made up of CBSDs, or the radios that are allowed to be in CBRS, and they can operate at a lower power, category A, or at a higher power, category B, and they are all fixed devices. Fixed devices means that you can't pick them up and move them around. There's an accurate location at which they have to be recorded with the SAS, and the device itself is a fixed operation. CBRS can operate with a domain proxy. The domain proxy may be used to report things through to the SAS. Generally speaking, if a domain proxy is being used when it's tested at the FCC, the CBSD and the domain proxy are tested together. Next is the end user devices. These are smaller power, lower power devices that don't exceed around 200 milliwatts. They do not exceed 23 dBm EIRP. They might be things like cell phones and other operating devices. Next slide, please. All right, in order to install a CBSD, unless you have something that can locate itself automatically, and at the moment I'm not aware of any device that does that, they may come in the future, you must use a certified professional installer. And a certified professional installer is someone who has gotten certification by a training program administrator that's authorized through WINForum. And they get training to get a certificate to be able to give the information necessary to the SAS. And I'll put a note just for our future speaker here on this webinar. Our first CPI was Dr. Andy Clegg, who was trained and is certified as a CPI. And by the way, he uses that for bragging rights quite often. You have to use the CPI to do installations. They have to do them indoors and they have to do them outdoors. So for category A and category B devices, a CPI is certified for 5 years, and that can be renewed, and their status has to be kept up to date at any given time. Let's move on. All right, so if you are interested in becoming a CPI, or if you want to know more about the training program administrators areas, this slide will give you links that you can use to find out information about the specifications associated with CPIs, what they're required to do, what they're required to report to the SAS, and also what TPAs do. I won't go into much detail there. I will note that at this point we have more than 4,000 trained CPIs. Next slide. All right, next slide. All right, I'm going to skip this one for right now. Yep, you can register with a SAS and they make the information necessary through the CPI. It includes such things as the serial number, FCC ID, make and model of the CBSD, interface type, authentication for the CPI itself, and authentication for the equipment is required. But do know that if you're using a CBSD, information has to be registered with the SAS. Next slide, please. And the next thing that you do is you request frequencies in a grant from the SAS. I will skip over this for time, but that's the important function of a CBSD before it can enter the ecosystem. Next slide. And here's a power comparison chart. There's one published in Part 96, shows you what a category A and a category B device the range of power that they must use and how high the antenna can be, as well as end user devices. Next slide, please. And I'm not going to go over the next slide because it just goes into greater detail, this information. If you look at this slide when you're going through the slides, you'll get a little bit more data. Next slide, please. All right, we can gloss over this one a bit, but the idea is that if you are using older equipment, you need to make sure that the equipment itself is certified for use in CBRS. It has to be able to operate across all 150 megahertz of the frequency. It needs to be controlled by the SAS, and it has to conform to the requirements of the CBRS band. So if you have older equipment and you're going to use it in the ecosystem, I would check with the equipment manufacturer to make sure it will work and is certified to work in the band. Next slide, please. And here is some of the regulations on using 3650 to 3700. If you are going to move over to Part 96, you will want to read this. Move on. All right, and here are some resources for using the regulations on FCC Part 96. So the electronic code directory can be found in the web, which gives you every aspect of CBRS, and the 2 locations for the baseline standards, which we call Release 1, and the baseline standards for Release 2 are given at these locations. Let's move on and skip this one. This is what the baseline standards look like. If you go to one of those locations, you will see that there is something that covers each aspect of the ecosystem. Reading the baseline standards and reading Part 96 are a really important way to enter the ecosystem. I would refer you to the WINForum website to look at the standards, and very easily you can find Part 96 in the ECFR. Next slide, please. All right, Release 2 is the secondary portion of what WINForum is doing, the updated portion of what WINForum is doing with the baseline standards. In order to be part of Release 2, you have to be doing something that will enhance or complement the CBRS system, and it adds features, functionalities, or capabilities to the ecosystem. It has to be backwards compatible. Most, if not all of them, are optional, which means that both the SAS and the operator or the CBSD itself have to be in line with one another and have to choose to be part of the additional capabilities. Some examples of release 2 capabilities are passive DAS in CBRS, enhanced antenna patterns, grouping, and flexible grants, and there are more. Next slide. And there are some specialized CBSDs. If you are in the field and you can't connect to a fiber or to a different frequency to do your registration, or somehow are not connected to the SAS, there's an ability to use a device called a CPE CBSD to connect your device, especially in rural areas. Slide 33. All right. I'm going to sum up here in order to do time. The next few slides just give some information about the markets and uses of CBRS. As you can see, it's being used at this point across many different kinds of markets. I will indicate, as it'll show you in the slides, in a couple of slides future, there are both private network capabilities in CBRS, public networks or standard commercial network capabilities, neutral host, which means that many providers can come through a single location, and the market and use is growing exponentially as we speak. So I think I'm going to wrap up here. I'll let Lee move along the slides. My recommendation to you is to embrace CBRS. Take a look at the things that the next 2 speakers are going to talk about, because they're going to tell you about some of the restrictions as well as some of the opportunities available in CBRS. I'm Richard Bernhardt. If you have any questions, please feel free to ask them and follow up with me. Thank you.
Thanks, Richard. A reminder to everybody who's attending, if you do have a question, please type it into the questions window and I will pass it on to the speakers. Our next speaker is Andy Clegg from Google. Andy, I'll turn it over to you.
Yeah, thanks Lee, and thanks Richard for the very detailed overview. So I'm going to go into a little bit of the information regarding the fact that the CBRS band is shared. It's not exclusively for CBRS. We use it when the incumbents, where and when the incumbents aren't using it. So I'm trying to give a little bit of detail of what some of those considerations are and what the impact on CBRS typically is. So let's go to the first slide here, Lee. So CBRS is a shared band. That is a fact. CBRS has a lower priority than the incumbent operators, so we cannot interfere with them. So that may impact operations at certain times in certain places. Some of the incumbents we protect are dynamic, meaning they transmit it sometimes and need protection, and they don't transmit it other times and don't need protection. Some are static. And so our protections of the incumbents will also be dynamic in some places and static in others, or perhaps even both in one place. And also keep in mind that there's 2 tiers of CBRS, as Richard explained. There's GAA, which is a lower tier, and GAA has to protect PALs, which are the upper tier. So if you're a GAA operator, not only are you impacted by the incumbents, but you also have to protect the PALs. And PALs also have to protect each other. So we have to keep all of these various things in mind. So we'll go through the various protection requirements that impact CBRS. However, I really highly encourage you, if you want all of the gory details, we wrote a very extensive document, which is WINForum Technical Report 5003, that gives all of the details on all of the protections for the incumbents in the CBRS band and how that can impact CBRS operations. It's a very lengthy document. It has a lot of detail. It has maps. It has other things. So what I'm going to try to give today is sort of just a taste of what's in TR 5003, but I highly recommend that if you want all of the details, please refer to TR 5003. We published that a couple of years ago, I think now, a year and a half to 2 years ago. Next slide, please, Lee. So a little rundown, Richard already did this, but there's sort of there's a few main things that we have to deal with in the CBRS band. One is incumbent radar operations of the Department of Defense, so federal government. Most of that is shipborne radar, but there are a few land-based sites that we have to protect. And so a lot of those protections are coastal and dynamic, but there are some dynamic inland protections and even some static inland protections of the DoD radar. Next slide, please, Lee. So there's also non-federal fixed satellite service earth stations. So these are, typically large dishes that are just receiving signals coming from satellites. So they are receive only, and we have to protect them from CBRS interference. In this band by FCC rules, the part of the CBRS band that's shared with earth stations, the earth stations in that part of the band can only be receiving international satellites. So what that means is that you'll have satellite dishes that need protection on the East Coast that are listening to European satellites that are way off over the Atlantic, and you have to protect some earth stations on the West Coast that are looking over the Pacific to satellites that are serving Asia. So you don't have any of these protections in the middle of the country. And then next slide, please, Lee. There also are general FCC rules that we have to respect, and those have to do with protecting quiet zones and coordination zones. And we'll go over this in a little more detail in a minute. Next slide, please, Lee. And then, as Richard mentioned, in the 3650 to 3700 part of the CBRS band, there are incumbent legacy broadband operations under Part 90. I'm not going to say a whole lot about those at this talk, because also, as Richard pointed out, those are sunsetting, and by January of 2023, so just a few months from now, all of those will be gone. They'll no longer be a factor for CBRS. So I don't think we really need to spend a lot of time describing those. So next slide, please, Lee. So let's look at the DoD protections in a little bit more detail. Next slide, please. So in the coastal areas, this is how we protect the DoD. If you just bear with me for a minute so I can explain it sort of from the ground up. What the government has done is has divided the coastal waters into what they call dynamic protection areas, or DPAs. You'll hear that term a lot, DPA, dynamic protection area. These areas are roughly a couple hundred kilometers on a side, roughly. They vary, but the entire coastline of the contiguous US is divided into about 50 DPAs, and then the entire coastline of the rest of the United States, such as Alaska, Puerto Rico, Hawaii, American Samoa, other places, are divided into about another 50 DPAs. So there's just over 100 DPAs total, but we're going to concentrate on the contiguous United States at this time. So a dynamic protection area is the most granular area in which we're allowed to know that the DoD is operating their shipborne radar. They don't want us to geolocate their ships to any better accuracy than a DPA. And so we have these constructs called dynamic protection areas that are the areas in which the DoD may be operating. So next slide, please, Lee. So then the next thing that you have to think about is the government working with industry has defined what's called a DPA neighborhood. And the DPA neighborhood is the area in which any CBSD that is operating co-channel to any radar activity in the DPA must be considered as a potential interferer. Doesn't mean it is an interferer, and it doesn't mean it's definitely impacted by operations in the DPA, but it could be. And what the DoD and NTIA and industry have come up with is a neighborhood distance. So in this case, for this particular DPA, which is off the coast of the mid-Atlantic, the calculated neighborhood distance is 368 kilometers. That's based upon propagation models and models of deployment densities of CBSDs and all sorts of other things. And so in the case of this neighborhood distance, this is for category B devices. And so any category B device that's co-channel with radar operations in the DPA, that's within 368 kilometers of the DPA, we have to do an aggregate interference calculation from all of those CBSDs and make sure that they do not exceed the DoD's interference criterion at any point within the DPA. If we calculate that the CBSDs in the aggregate are exceeding the interference objective at any point in the DPA, we start removing the worst offenders from the top of the list until we get down to the point where the aggregate interference is less than or equal to the interference criterion. And so those that had to be removed will either have to get relocated to another frequency or reduce their power or perhaps even go off the air completely. It just depends on the situation. Next slide, please, Lee. So the way we know whether there's activity in the DPA and what frequency it's at is that we monitor it with the environmental sensing capability, ESC. And here I have sort of a simplified version of how the DPA is covered. We may have a sensor that's north of the DPA, at the north boundary of the DPA, pointing south into the DPA. And then we have another sensor south of the DPA pointing north into the DPA. And this is for two purposes. One is to make sure we can receive from all points in the DPA if a ship is operating, but also we do this for redundancy. If one sensor goes out, we may be able to cover the entire DPA with the other sensor. But this is typically how we determine whether there's activity in the coastal DPA. Next slide, please, Lee. This is showing a map of all of the DPAs in the contiguous United States. Those are those areas outlined in red and their corresponding neighborhoods, which are the areas outlined in green. One thing you'll notice is that a given point near the coast can be within more than one DPA neighborhood. And in fact, on the East Coast, there are points that are in up to 13 DPA neighborhoods. So the activity that impacts that particular point on the coast is not just worried about the activity in one single DPA, but it has to look at the activity in 13 different DPAs in which it's in the neighborhood. So just a little bit of a complicating factor. The next slide, please, Lee. One downside of having sensors on the coast to detect activity in the DPA is that those sensors themselves have to be protected from interference so that they can hear the signals. The DoD's radar is very strong, power-wise, but the ships could be very far away, a couple of 100 kilometers or more. And we have an interference, we have a detection level that's set by NTIA that we have to meet. And in order to be able to meet that, we need a 20 dB signal to interference ratio. And so we may have to mitigate the operations of CBSDs in the area so that they do not exceed the interference criterion of the ESC sensor itself. And that sensor, all of the sensors, ESC sensors, operate across 3550 to 3650. So these, what we call WISPA zones that can impact CBSDs, impact the entire 3550 to 3650 portion, so 2/3 of the CBRS band. So it's an issue, and as Richard noted, we're trying to get away from the use of sensors to determine DPA activity and move to a method where the DoD proactively tells us, not over the air, where and when they're operating, and so that we can reconfigure accordingly, and we won't need any sensors in order to sense them, and so therefore no WISPA zones. However, this is several years away at best, so we will have ESCs for the foreseeable future. Next slide, please, Lee. Great. Already spoke about this, so we can move to the next slide, please, Lee. So there are a few, when I say IIC, what I mean is the informing incumbent capabilities when the DoD, for example, goes to a portal and says, and schedules activity. In this DPA, we're going to be active from 2 to 4 p.m. next Tuesday or something like that, and puts that into a calendar. We already have a basic version of this running now, but the DoD does not feel that it meets their requirements from operational perspective. So it's not used very much. They're building their own portal that will tell us when they are operating in certain areas that are not monitored by ESC. So these are these inland sites that we don't use ESCs to monitor because the types of radars they may be operating there don't fit the same mold as what they use on the ships, or they may even be operating passive systems, so we couldn't detect them with a detector even if we wanted to. So these are the portal managed DPAs in the contiguous US, a little hard to see, but if you go to the next map, please, Lee. This is the portal managed DPAs with their DPA neighborhood shown around them. So some of the portal managed DPAs are point sites around the country, and some are spread out, but their neighborhoods do in fact impact populated areas. So when and if the DoD tells us by the calendar portal that they're operating in one of these portal managed DPAs, it has the potential to impact a significant population on the frequency that they're operating on. Next slide, please, Lee. Some of the portal DPAs also require protections below 3550. So this is a little bit of a new concept. They can tell us that they're operating below 3550, and we have to manage CBSDs that are within 25 kilometers of those sites, such that their predicted impact to the operations below 3550 do not exceed a certain interference criterion. So it is a consideration that even though the DoD may not be operating specifically in the CBRS band, we may still need to protect them from out-of-band interference. Next slide, please, Lee. So then there's finally a few sites around the country. We call these GB3 sites because the radar that operates there, the DoD refers to anonymously as ground-based radar 3. These are areas that are protected from CBRS out-of-band emissions at all times. In other words, we must protect them from out-of-band emissions, whether they've indicated that they're operating there in these sites or not. We have to presume they're operating at all times. The category B neighborhood distances around GB3 sites, it's pretty small. It ranges from about 2 to 13 kilometers, depending on the site and also the particular CBRS channel you're on, because the out-of-band emissions go down the farther you are away from the 3550 megahertz border. The category A neighborhood distance is very small. It's a kilometer for all GB3 sites. But we're in the midst of working with DoD to reconcile the need to protect any of these sites below 3550 from CBRS out-of-band emissions, given the fact that the 3.45 gigahertz service is coming online now, and they're allowed up to 3,000 watts per megahertz of in-band power below 3550. So to us, it doesn't make any sense that these sites need protection from very weak out-of-band emissions from CBRS. We're working with the DoD trying to mitigate the requirements for these protections. Next slide, please, Lee. I think it's a map of the GB3 sites. So this is the GB3 sites that I've added a nominal 8-kilometer category B neighborhood distance to. So just give you an idea of where they are. Next slide, please, Lee. Yeah, very quickly, there are a few exclusion zones the DoD has set up for us. Next slide, please, Lee, map. So there are 3 sites that are always on exclusion zones in 3650 to 3700 that are shown by the circles there. Those are 80-kilometer radius around certain sites. And then there's the Nevada test and training range that is an always on exclusion zone in 3550 to 3650. So we cannot operate there at those frequencies at all. Next slide, please, Lee. So how often does DoD radar activity impact CBRS? That's the million-dollar question. We get asked this a lot. It depends on location and frequency. And like I noted, some exclusion zones are always on, or out-of-band emission protections are always on. People mostly ask us about coastal DPA activity. The DoD at this time does not allow us to release statistics, detailed statistics, location-based statistics of the activity rate, but the government itself did a channel occupancy study in 4 places. They looked at the CBRS band 3550 to 3650 and looked at the activity of DoD radar in the San Diego and Norfolk area, and also off the coast of Oregon and San Francisco. And San Diego and Norfolk are very heavily utilized Navy bases, and what they saw was an overall rate of about 14% occupancy by the DoD radars. Whereas Oregon and San Francisco are not near Navy bases, active Navy bases, and the activity there on a long-term average was less than or around 1%. Next slide, please, Lee. So I added some resources for more radar information about the DoD operations, including TR 5003. Next slide, please, Lee. And then we'll quickly go over fixed satellite service protections. These are fairly simple. Next slide, please, Lee. These are effectively static. What is done is that there's a 150-kilometer zone with surrounding FSS Earth stations that operate below 3,700 megahertz. And we have to calculate the aggregate interference from CBSDs in the area that are co-channel with that FSS Earth station and make sure they're below a specified level at the location of the Earth station. So much simpler. It's a static operation, much simpler than DoD protections. There are a few satellites receivers that operate above 3,700, and those that are used for TT&C are also protected from interference from CBRS, but those are relatively few already. And now that 3,700 and above has been reallocated and those systems are moving out of the band, they're certainly going to be less of a factor going forward. Next slide, please, Lee, with the map. These are the 150-kilometer zones surrounding the sites that are eligible for protection. Gives you an idea of where you may be impacted due to protections of FSS, not necessarily impacted, but potentially. And then let's go forward, Lee. This is the 40-kilometer protection distance for adjacent band sites. So then finally, quiet zones and coordination zones. If you go to the next slide, please, Lee. Part 1 of the FCC rules basically require numerous radio services to respect coordination zones and quiet zones around the country. The big one there in the West Virginia border is a national radio quiet zone. We are able to start offering CBRS service there based upon an agreement with the National Radio Astronomy Observatory, but you need to contact your SAS to understand how that's possible. The circle there in Colorado is the Table Mountain Coordination Zone that the Department of Commerce runs outside of Boulder. And then you'll see numerous little dots around the country. They're 2 to 4 kilometers in radius. Those are FCC field offices that have to be protected. And basically contact your SAS because operations in these areas are possible. We just need to coordinate in advance and make sure you don't exceed interference thresholds. Next slide, please, Leah. I think I'm just about done. Yeah, this is just what I said about the previous map. Next slide, please, Lee. And then finally, border protections. Next slide. We have to protect the Canadian border, and we also are required to respect any international agreements with Mexico. Right now, there are no international agreements with Mexico, so Mexico border is not a factor. Canada is a factor. Right now, we, I don't want to go into too much detail because we're working on a revised coordination agreement with Canada, so some of the requirements here are going to change. But basically, if you're 8 to 56 kilometers from or within 56 kilometers of the Canadian border, you might be impacted right now. But again, contact your SAS administrator. And we do have to protect one Canadian fixed satellite service Earth station. You see it there. Part of the 150-kilometer coordination zone dips into the state of New York, but it's not really a major factor. Next slide, please, Lee. Yeah, so my main conclusion is, number one conclusion is refer to TR 5003 for a lot more detail, and also talk to your SAS administrator to better understand all these. So anyway, there we are, and we'll pass it on. Thanks, everybody.
Thanks, Andy. If anybody has any questions, please enter them into the chat of the questions window. At this point, I'll turn it over to Mark Gibson.
Okay, Lee, thanks. Move ahead. Actually, go ahead to 2 slides. I won't dwell on the title here. Next slide. Oh, I didn't know I had animation there. Go ahead one more. So we don't have a whole lot of time to get into what's going on right now. Talk about the CBRS update and hopefully some time on use cases. So go ahead to the next slide. And there shouldn't be any. There we go. So As everybody knows, we had an auction, generated nearly $4.6 billion. The two takeaways from this slide are the number of winning bidders and the number of qualifying bidders, more than in any other auction. So some people look at CBRS auction and say, yeah, only 4.6 bill, but you know, it would have more participation because of the license areas, which were counties. There's the top 20, and so far we've granted, the commission has granted over 17,000, almost 18,000 licenses, which is a lot. There were a total of 23,000 that could be granted. Next slide. However, what's happened since we last talked is we have some new neighbors, and they're a little loud. CBRS, you see in the middle in blue. Shortly after CBRS was allocated, or the auction happened, the C-band auction happened, and we've got now, we'll be having a lot of high-powered base stations that can operate up to almost 66 kilowatts per channel. And then we've got 3450 that can operate half of that per channel because the channels are smaller. So the key takeaways from this slide are what we're doing about it. And so the upper side, we've worked on coordination. In fact, we have a protocol we're talking around coordination. Andy and I and Richard have been working on this to help with how we can deal with things like RF interference, frame sync issues, because all of this is TDD. And so there's some guidance in that the commission or that the forum has to how to address, you know, dealing with our noisy neighbors. So next slide. I wanted to tell people about how this has grown. So the CBRS has grown a lot in terms of CBSD count. As of yesterday, it was about 231,000. It looks like it's leveling off a little bit just in terms of the activity, and that's mostly just because it is actually. We're adding about several thousand a month. That little anomaly on October had to do with an issue in data. There was an issue in data reporting, so that number in October should have been close to the ones in the previous month and the one after it, September, as well as November. But the bottom line is we have nearly over 200,000 CBSDs deployed so far in 2.5 years. That's a lot of CBSDs. Next slide. Now the makeup is remarkable Cat B. It's really, most of them are Cat B. A lot of that is because of the Part 90 transition, which is beginning to tail off. I'll mention that again in a moment. And we have Cat A both indoor and outdoor. Cat A outdoor doesn't really look a lot when you compare it to the overall amounts, you know, and we're not supposed to give numbers, so I won't in terms of the breakdowns. But there are the takeaway from this slide is that there's still a lot of Cat Bs, and Cat As are now beginning to increase in the amount of deployment, both indoor and outdoor. Next slide. In terms of PAL licensing, the commission awarded the licenses. There were 17,703. And then, as you all know from what Richard said, PALs, once they are declared in a market, they have a PAL protection area, and that is reported to the SASs. And so when you look at it, there's a lot of licenses in the lower portion of the band. Actually, and Channel 1 has more than any other, and that's mostly because of Dish. Dish selected Channel 1 and 2 and 3, most of the channels at the low end. So they bias that a little bit more. So you see the purple, if you see purple, is the number of PALs awarded, and the blue is the number of PPAs. So the number of PAL protection areas is coming on, and we should see that number increasing substantially as we get more PALs, more PPAs. Next slide. So just to summarize the activity, Part 90 to 96 transition was really what caused a lot of this, the Category Bs. That's winding down, and the deadline for that transition is January 8th next year. So we're pretty much at the end of that. PAL channel assignment began in earnest a year ago, so that's been ongoing. And again, you have 7,000 PPAs. The secondary market has been slow to develop a market. A lot of that has to do with where the commission is. We're sort of trying to work as SASs with the commission to get the ULS up to speed. It's happening, but it's slowly, and more work is going as we do that. As I mentioned, the adjacent band coordination is happening now, or at least we're working on protocols to do that. I don't know that SASs have been pinged yet to do any coordination, but we're available and ready to have that. And as Andy said, I think Andy talked about WISPA zones. We're also working on the ESC interference protection with respect to WISPA zones. So next slide. And try to spend a minute on the use cases. Oh, actually in this one. So there's a thing out there, there's a proposal for high power, and I felt like I'd be remiss if I didn't address that. What you see here is the power, and this is a slide that Andy did a while back just to show proportionally what the CBRS power looks like compared to the high power on the adjacent bands. There's been a proposal put forward by Dish that others have put this forward before to increase the power for CBRS. So right now we have 5 watts per megahertz or 50 watts per channel for the Cat B. If you go to the next slide, and it's that little green sliver there at the bottom. This is what Dish is proposing, 2 new categories, which is a C and a D. The category C is a little bit more, 158 watts per megahertz, and then so it'd be 1500 watts, and then category D would be 15,000 watts. So it's kind of on par with the rural or the urban powers for the CBR or the C band and 3.45 gig band. Next slide. And I'll probably wrap it up with this one since we're done. Use cases. If you go to the next slide, I've got a really high-level slide on private networks. Actually, go to the next slide. One of the things that the band opened up was private networks. Yeah, next slide. There we go. So these are the applications that CBRS opened up, which are pretty much standard deployment: fixed wireless broadband, mobile capacity augmentation, footprint, alternative mobile footprint, which is actually supported a lot by the cable companies, and then in-building cellular. What happened was this nexus of the ability to have your own network inside your building with private LTE, and that's what SAS enabled. And so there's a couple more slides in this deck that address the private networks and just other use cases that you can review on your own. The takeaway from all of this is, maybe just to summarize, is we're 2.5 years in. It's working, it's successful. We're generating a lot of new and exciting use cases. CBRS was used heavily to address COVID in terms of triage centers at hospitals where people didn't want to be going into the ED. They would show up to a tent that was outside, and they were using CBRS to backhaul registration information to the hospital. We had some of that going on with some of our stuff. So I'll leave it there. We're at time, and I'll turn it back to Lee for wrap up. And thanks.
Sure. So we'll go through questions. If folks have any questions, please type them into your chat window or the question window. The first question we've received is, what's the difference between a DPA and a default protection contour? Andy, maybe that's a question for you.
Yeah, so a DPA is where the DoD would be operating, the Department of Defense would be operating their radars or whatever else they want to operate. A default protection contour is something that's established around a PAL that determines the contour around which the PAL is protected. So I guess the basic distinction is a DPA sets up expectations of protection for DoD operations, whereas a default protection contour sets up expectations for protection of a priority access license operation. Richard may want to say more.
No, I think that accurately portrays the difference. So unless there's a more specific question.
Okay, any other questions from the audience? Give 1 more minute for folks to type in questions if they have. Okay, well, I'll thank our speaker. There's no additional questions, so I'll thank our speakers, Andy Clegg, Richard Bernhardt, and Mark Gibson. And again, the slides and recording will be posted later today if folks want to follow up on them. And thanks everyone for attending. Look forward to seeing you at the next webinar.
Thanks.
Thanks.
Thanks, everybody.
Bye.